Hello everyone. Today we are going to build our own GPT. Basically, it's a small GPT which can generate a name. So that's why I called it NameGPT. Definitely, it's not gonna be as advanced as ChatGPT. ChatGPT has a lot of algorithms which make it very powerful. But through this video, you will learn the concept how GPT works. So yeah, let's begin. I'll start with creating a test data. So let me add first file and I'll create a file which will contain names. So these names are basically for the training of our GPT model. And once our GPT model is trained on these names, we will be able to generate new names. So, and I'll be using mostly Indian names for this, but this algorithm should work pretty fine for non-Indian names as well. So yeah, let's begin. I'll create a final names dot JSON file, and I have collected quite some names here. So you can see here around I have 6,500 names available here. And if I go to the top of the file, yeah, you can see Shivani, Isha, Divya, Mansi, and I have names for males as well. So if you go, then you'll find in the bottom, like we have Asfaq, Sahid, Parish, Mehraj. So we have a very good set of name here. And if you notice, I've started the name with uh, the angular bracket and closing with it with an angular bracket. Why I did this? It is just as a marker, so it tells me that okay, name is starting from this and ending from this. This just going to work as a marker for us. So yeah, we have our training data ready. And now let's understand the concept of the GPT, which we'll be making here. Yeah, so let me open a slide and I'll explain what I'll be building here. So you must have heard about token when you talk about GPT. Basically, a token is something like a word. Uh, so we also need token for our algorithm. So in this GPT, what I'm doing a character-based GPT. So chat GPT is entire text-based, I mean the word-based. So one word is something similar to a token there. In our example, one character is one token for us. So you see around 28 tokens, basically 26 alphabets, and then end character and start character, these two. So let's see how our GPT model going to work. We'll start with making a count matrix. So what is a count matrix? So let's suppose we have these 5 or 6 names for our training, and we want to build a GPT on top of the 6 names. So uh, what we will do, we'll start with each character and we will see what are the next character adjacent to that. For example, if I talk about S, then the next character is H. So what we will do, we'll create this matrix which have around 26 into 26 dimension, and we'll go to S, and we'll go to H. So we are here SH. So you see SH have found two because there are 2 times we can see SH. One is here SH, and then all the way here SH in Isha. So that's why it's 2. Then if I go for HI, then we can go here H, and then we can go I, and we see there's a 1 count. So this is uh, I followed by H. Sorry, H followed by I. So that is 1. And then we talk about IV. So then we'll go to I, and then we will go all the way up to here V. So we see the count is 2. So if you see, Shivani has IV, and then Divya also have IV. So that's why the count is 2. So similarly, we'll create this matrix for all the pairs of characters which is there in the names. Once we have this matrix ready, then what we have to do, we have to convert this matrix into a probability matrix. Basically, what is the probability that uh, if current character is A, then the next character will be N or Z. So you can see there are total 3 count. So A is followed by either by N or Z. And the total count is 2 plus 1, which is 3. So there are 66% chances that N will be followed, N will be coming after A, and there are 33% chances that Z will come after A. So let's see what I mean here. So we took the first row, and then we sum the all entries available in for that particular row. So here if you see 2 plus 1, which is 3, so I've added 3 here. Now to calculate probability, what we have to do, we have to divide the n, the number of the term, with the sum. So if you see here 2 by 3 and here 1 by 3. So basically which is 0.667 or 0.333. So we can say A will be followed by N 66.7% time, and A will be followed by Z 33.3% time. So basically, given the data set, only the 6 names, we can say A will only be followed by these 2 characters. But definitely, we have more than 6,500 names. So this probability matrix or this sound matrix will really different when we actually going to calculate this. So yeah, let's begin. So we have our name ready, and what we will be doing next is we'll be creating a file which will basically train our model. So we'll call it train diagram model.js. And I'll not be using any packages, pre-existing packages. So I'll be writing everything from scratch so that you can see what's going inside. So let's begin. So I'll be reading the names first. So I need only one package, which is to read the file. And then the very first thing which I'll be going to do is to create a character and integer map. So basically what I'm saying is I'll be creating something like A, and A is let's suppose 2, because we have 2 more characters. So we have this character, basically another bracket, which we'll call it 0 index, and then we have one more another bracket, so I'll give index 1, and then I'll be doing it for B, and then the rest up to Z. So this is a map which I'll be creating. So let's create a map. I'll say character to integer map, and I'll be setting few values like this as 0, this as 1, and I'll be running a loop which will be from let I is equal to 97. So 97, if you know, it is basically small a, to I is less than equal to 122, which is Z, and then I plus plus. And then I'll be converting that particular in I to its corresponding character, and I'll be building this uh, uh, basically the map. And what I'll be also doing, I'll be having index, and I'll be setting it to 2. and I'll be saying index plus plus. So let's run this and see what happens. So to run this, I'll go here, I'll type node and then train diagram model.js. Do this, and if you see here, so we have 0, 1, 2, all the way up to 27. So we have our dictionary ready. Basically the lookup table is ready. And what I'll be doing, instead of writing it in console, I'll just write this in a file. So I'll say file system dot write string, and I'll say c2i dot json, and then I'll be writing this file in a JSON file. So yeah, now what I'll be doing next is I'll be creating a count matrix. So the similar to this example, I'll be also creating a count matrix where I'll be having basically 28 into 28 because A to Z is 26, and then we have a start marker and end marker. So I'll be creating 28 into 28 matrix. So yeah, let's do it. So that is 0, 5 is 10, 28, 5 is plus. And let's have this matrix here. So I'll say constant matrix, thank you, matrix. And I'll be creating rows, and I'll be setting everything by default 0. So for that, I'll be pushing row to 0, and then I'll be appending that particular row into the count matrix. So basically, it's gonna form a 2D matrix for us. The one thing to note here, by default it is 0, but I will not keep probability 0 for everything. I mean, let's understand that with example. So if you see D, here we have D, and I'm saying that D is never followed by B. So it is possible that the names which you have does not contain an example where D is followed by a B. So similarly, we can have multiple such example and multiple values will be 0. So what we will be doing here, we'll be not setting anything to 0, and we'll give a seed value to everything. So basically what the seed value will be, so the seed value, I'm going to keep it as 1. So the count is by default 1 for everything, except if it is an ending character. So if it is basically an ending character, which is this, which is this 0 index, so what we'll be doing, we will be setting everything to 0 because anything can't end with n and then start with something. So there's no probability that end is followed by A, B, or C, anything, any character. So let's adjust that. So if I'm saying if I is equal to 0, then I would say it's 0 because it's an ending character. But if it is not an ending character, then I'll say, okay, keep it as 1. So basically our count matrix is ready. And if I uh, run it, so we can see how our count matrix look like. So yeah, you see, everything is set to 1 except the very first row, which is for all the ending characters. Cool. Once we have count matrix ready, the next thing which we have to do is basically to count. So to count, we first need to read all the names. So I'll say all the Indian names, and I'll be reading all the Indian names here. So we have 5 Indian names. Let me just rename it. It is final names.json. And what I'll be doing, I'll be looping through all the names. So because I'm reading this file as a string, so let's convert this string to sorry, JSON. So let me create a JSON out of this string. So yeah, I have all the names here as a JSON. So let me just log it and show you. If you see, I have all the names available. Now, once I have all the names available, let's create a count matrix out of this. So for name, I'll be looking through all the names of Indian names. And then what I'll be doing, I'll be basically looping through all the characters which I have. So we'll say name length is equal to name dot length. And then so what I'm doing here, I'm going through all the characters which is available in that particular name. And I'll get the first character from here. So I'll say character one is basically name I, and I'll be saying get the next character, basically name I plus one. So I get the very first character. So let's suppose if the name was Sham, so name length is 7, and then the first character will be N, and the the next character will be I, and it will be will loop through all the characters. And then what we'll do, we'll look into our character to integer matrix and then get the uh, value of that from that lookup table. So let me just say constant get the character index and then character index from next from the C2I table, and then to update your count matrix. So now I'll go through all the names, I'll go through all the characters in the name, get the uh, C2I mapping of those characters, and then increment the count matrix for that particular row and column. So let's see how it looks like. Okay. So yeah, if you see here, you will see all the values available for your data. So awesome. We have our count matrix ready. So what was the next step? We wanted to create a probability matrix using the count matrix. So this is ready. And the next step is to create a probability matrix, basically converting the count into probability of something happening. So let's do that. For that, what I'll be doing, I'll be creating a probability matrix. And then I will loop through uh, all the characters which we have. So we have 28 characters. Also, I will loop through all the characters and what I will do, I will get the sum, row sum. I'll say row sum, and I will get the row sum for that particular row. So for the first row, I'm saying to generate all the to sum all the entire column for that particular row. And let's see if it sums fine. So I'll be logging it here, run it, and yeah, you see you have sum available for each row. Once we have sum ready, the next thing is we'll we'll go through the count matrix and then convert that count matrix to a probability matrix. So let's do that. So we will create row. We'll go to the count matrix. We'll take the count of each cell, divide it with row sum, and then we'll get the probability. So if you remember here, we'll go through all the cells and we'll divide it by the sum. So basically 2 divided by 3, 1 divided by 3, and so on. Yeah. So this will give us the new probability row, and then we're just gonna push it in our probability matrix. And now let's see how our probability matrix look like. So yeah, if you see, we have a probability ready for all the characters. And okay, so the very first character is showing not a number because if you remember, the entire row was uh, 0, and because of that, we cannot divide 0 by 0. So that's the problem. So to fix it, what we can do, we can just add a small check here. If or you can just skip the first row so that it doesn't count aggregate for that. And if you run again, oh sorry, uh, okay, my bad. You cannot skip because we are pushing it. So what we can do, we can say if I is equal to 0, then you just create a row and fill it with 0 and just push it. That's it. What we can do now, you see, the first values are 0 and all other values are calculated correctly. Once we have probability matrix ready, we are going to store this matrix in a JSON file so that we can read this data for our next uh, uh, experiment. Basically, we're going to use this particular model to use in our GPT. So I'll be writing this now, probability matrix or JSON file. And let's run it. And we will get the probability matrix here. Let's format it. And yeah, we got uh, probability for all the characters followed by every other characters. Yeah, so far so good. Now let's begin to build our GPT on top of this. So we'll call it name from GPT. So by the way, I'm calling it bigram because we are considering only two characters. So the first character is followed by the next character. Uh, we will soon be building ngram GPT, which will have much better generation capability, which can generate a better names. But yeah, ngram will be a complicated one. So wanted to start with a bigram one, where you can just understand how two characters are linked, and then we'll go for a higher order. So here also I have to read the file, basically the probability matrix I have to read. So I will say probability matrix, and I'll be reading our probability matrix JSON file. And I'll be using the C2I file, which is basically the character to integer mapping file. So I have to both the data ready here. And I will also create a I2C basically mapping. So when I have an integer, I can convert that integer to its corresponding character. For that, it will be very simple. I'll say I2C, and I'll be just looking through all the keys in C2I and just converting into a I2C matrix. Sorry, I2C mapping. Yeah. Now, the next thing which we have to do is basically we have to write a method which can predict what will be the next character when I have an input a character. So for example, I will say generate random character after, and then we pass a character here. So I'll be passing a character and I'll expect this function to return a random character to me. So to generate a random character, we'll start with a random number first. We'll say random number and we'll just generate a random number between 0 to 1. So this will be 0 to 1, any number it can generate. And then what we'll do, we will figure out that, okay, uh, which is the random character based on the probability we can return. So let's see example how it gonna work. So let's suppose the start character was this, and A has 10% probability, B has 30% probability, C has 70% probability or 60% probability. Then when you input uh, start character, how will you return A, B, or C? So the basic idea is when user input this, then A should come once, B should come thrice because it has 30% probability, and then C should come 6 times, and then you pick a random character out of this. So to pick a random character, you can use math.random function, and if math.random function is, let's suppose 50, it gives you 0.5, which is like 50%. So you can actually go and sum up the values. So it has 10 and 20, 30, 40, 50. So if the 50% value is there, then you will return C. But if it was 30%, then you can say 10, 20, 30, and you will return B, like that. So we'll be using this method where you'll just sum up the probability and then return the random value to return a random character after that. So it will create a sum. And then what we will do, we'll basically loop through all the characters, basically 28 characters. We'll get the probability from the probability matrix which we have. And whenever we find that random number is less than or equal to the sum, we will return that particular index. So that should be fine. So it will return that particular character. So now we know that, okay, given a random character, given a character, this particular function will be able to give us a random character based on the probability which is we have generated in the previous exercise. So now let's write a function which can generate names for us. And this method will take input, which is basically the start of the name. And by default, the start character, I'm putting it here, where is start character, this character is the name. And let me build a name. So basically name will be start character from which you are starting your name. But of course, if it is the start character, then we'll just keep it as a blank, and otherwise we'll keep it as start. It's just to make it clear. And then let keep the current character as start. So now while we're running a loop where I'll be running it for a particular condition to be met. I'll say next character. I'll say, okay, I need to get next character. Or to get next character, I'll say generate random character after and then the character. Once we have this character, we'll check if this particular character is the end character. Basically, this is the end character. So we will break our loop. That okay? We don't need to generate it further. Otherwise, what we'll do, we will add that particular character to the name. And yeah, this should be fine. And then we can just go ahead and return the name. So yeah, our name generation using a diagram model is ready. So let's see. I'll say log with the first name. So let's run it. We'll say name diagram.gpt. And yeah, it generated a very weird name. So yeah, what's wrong? Because it's just a diagram model where one character don't know uh, the context of the entire string. So we are predicting the next character based on only one character. So this is very much possible that you get something like this or even weird names. But definitely, this is not what we are looking for. We are looking for a better, precise name. So let's fix it. Yeah, I found the issue. So the issue is, even though we are generating this character, we are not changing this character. So this character is always every time the same character. That's the problem. So I'll say character is equal to next character. Yeah. So now it should give us the good result. Yeah. Still not a very good name, but you can see it's coming to some point where it is uh Praujes Kala. Very weird name. Mir, yeah, Mir is a common name. A lot of people have heard the name Mir. Then again, some random name which is very big. Ganukai, pretty good, though I don't know if there's actually a name with Ganukai. Alabia, maybe. Definitely FAF is not a good name. Jatifi, then again something random, some random. Pa, pa, ni, no, har, no. So you can see, though it do generate names up to a certain extent, but it is not very good in generating them. But with this, you got a concept that how it actually figures out what to print or what to generate of with a given character. Mahaman, pretty good, I would say. Before that, Vibhuti, okay. Roshiro, uh, and it doesn't sound like the name. Harin, could be. So yeah, you understand. Based on this bigram model, you can build a GPT which do generate some names, but not very intelligently. So what's the solution? The solution is to build a GPT which is not more than a bigram model. So it can go to 3, 4, or 5, or 6, 7 character long. So let's do that. To do this, I'll create a file called build ngram, or maybe build ngram probability matrix. I'll be using the same names to generate this particular probability matrix. So for that, very first thing I'll take is ngram. So I'll start with 5 characters. So basically, based on the last four character, you say what would be the fifth character. So let me show you example. So if the name is Nishant, then I know that when M is the string, I is the next character. Similarly, when Ni is the string, S is the next character. Similarly, when NIS is a string, the H is the next character, and so on. So what we'll be doing, we'll be building something like this, where based on each character we know. But again, as I told, I'll be doing it for 5 right now. So let's build till it will be actually working till here. Okay? So when NISH, A is a character, the next character will be N. So this will be the probability. So let's build it. I'll be reading the file for all the new names, and I'll be reading all the new names from final names.json. And I have to generate a lookup similar to the matrix which I have generated here, similar to this matrix. This was for bigram. So given one character, you can predict what is the next character's probability. I'll be creating a object which can store it for up to n gram, which is 5 here. So let's build a function. We'll say generate n-gram lookup. Okay. And basically this will be the count. So this particular lookup table will contain the counts for different characters. So let me show you what I mean. So for all the names of Indian names, I'll be running a loop, and here I'll go through all the characters. I'll be doing for I put 0 as less than name dot length, and I'll be running it for minus n time because I only want to get to a point where length of the name minus this n. So we don't want to reach to the end because we can't actually reach because we have to go to this point. So let me build it and then you'll understand what I meant to. So get me the first n-gram. I'll say name dot slice and you get me up to this thing. So let's log it and see how it looks like. I'll just log this and I'll run this. thing. Sorry, I have to call this function and I have to pass. Let's pass right now too. So if you see, this is for 2 characters. Let's do it for 3 characters or maybe do it for 5 characters and run it. So you see, I have these 5 characters, which is basically saying n-gram. So we have CHOTU, we have to predict what can come next. So for that, we have to store the count. Okay. So once we have n-gram, let's get the next character. So basically, next character is name plus name, the ith character plus n. And check if then what we'll do, we'll create a lookup object. So I'll say count lookup. I keep it empty object right now. And then you check if that particular n-gram don't have any object inside, then you just add an object blank object inside. So basically, let's suppose the n-gram was Chotu, then our lookup will become something like this. Chotu, and then it will be like this. So basically, this will keep Chotu will have probability for different characters. So what is the probability of A coming after Chotu, or what is the probability of B coming after Chotu? So those things will be stored in this lookup table. So let's do this, and let's check if there's no data available for that particular thing. So as I have given you example here. So if you have Chotu, and if it is blank, there's no entry, then you go and create an entry for A and initialize with 0. That's why I'm initializing with 0. So let's do it. And then just increase the count. So we have our lookup ready. So what we can do, we can actually go ahead and generate lookup till n. Basically the 5 gram. So let's do it. For yeah, for I is equal to 1, starting with 1 till n, generate n gram lookup for I. And once we have lookup ready, what we can do, we can write this lookup, count lookup in a file so that we can see how this data looks like. Let's run it. Yeah. So we have n gram lookup is ready. Let me just format it. Yeah. So here we are. You see, we have so many data generated. So yeah, if it is a starting, then S has very high number of count, then I followed by D. So there will be a lot of names which start with S. Then there are a lot of names which start with I, and similarly like that. Similar to that, let's go to other thing. So if R and V are together, then E have 17 count, A has count enabled. So R, V, E will be around 17 in your name, final name.json. R, V, A have 11 count, R, V, T have 1 count. So let's search for R, V, T and make sure we are correct. So if I come here, I search for R, V, T, and you see we have only one R, V, T, which is uh, Parvati. Parvati. Yeah. So yeah, we have our lookup table ready. And once we have lookup table ready, we build our probability lookup. So how we build our probability lookup? The same thing. You take all the individual values and divide it with the sum in that particular row. So let's do that. For that, I created a probability matrix object. And in this particular object, what I'll be doing, I'll be running through all the n-grams which I have in the lookup table, and I'll create a n-gram probability of n-gram probability object. Uh, so basically what I'm doing here, for every n-gram, I'm creating an empty object inside this. So basically, this will be appended at last into this. So let me show you what I mean. Then you figure out the sum of each particular values. So I'll say total, and then you go through all the count lookup for that particular gram, and then find the summation. So what I mean, if you go to your gram lookup and go to any example, let's suppose I'm here, KU. So you create a sum of all this. So 13 plus 23 plus 26 plus 9 plus 16 plus 26 plus 1 plus 2 plus 2 plus 1 plus 1. So this is the sum of KU and gram. Okay. So let's do that. So I'm doing that, the total. And then you create a probability out of that. So for all the character in that particular graph, basically for S it's 23, so 23 divided by the total sum. So what I'm doing 23 and then divided by the total sum. So far so good. Once you have this ready, then ideally it should able to give us n-gram probability lookup. So let's save it and yeah, run it. Let's see what it builds. So it breaks here. Sorry, why maybe it's not declared anywhere. Why not? I have chosen a different name. So let's keep that same name. So we have n-gram probability matrix. Pretty bad. Let's format it and see how it looks like. Cool. So we have around 46,000 rows. And let's go to the top. And if you see, S when we are starting a name, S have around 18% probability that the particular name will start with S. Then I have around 1.5% probability. We have 4.5% probability. M have 8% and so on. And W have around 0.2% probability that the name start with W. And definitely W is very uncommon names here. Z also very uncommon. O, I heard only one name, Om. But yeah, so you can understand. And definitely S is very common name, starting name, starting character for the names in India. So yeah, you see high probability of this. So cool. You have n-gram probability ready. And then what we have to do next is we have to build the n-gram GPT model. So we should always remember that our n is 5 right now. So let's do it. And say name GPT n gram dot yes. And in this particular file, in this particular code, we will be reading that the probability matrix. But before that, just set the n to the same value, and then we read the probability. So I'll say constant n-gram probability lookup, and you read the file n-gram probability lookup, and then you have this probability lookup table ready. So now what we need to do, we need to generate random characters after the given string. So generate random character after n-gram. So if you remember in our previous example, in the bigram model, what we did. So let's open the bigram model. Yeah, name bigram GPT. And here I was expecting one character from user and then returning the next character. But in this example, I'll not expect one character, I'll be expecting n character from user and then I'll be returning a random character. So let's generate a random value here and then create a some variable. And what I'll be doing next, I'll be creating a tuple, which will be basically your n-gram. You'll get it from n-gram probability lookup. So you receive that particular object. So I'll not call it tuple, I will call it lookup object. So you have a lookup object, and then you sum all the probability of the lookup object and return the key. So yeah, our random character generator is ready. So let's see how it works. If there's NIS H, this is the input character, and again it's a 5 gram, so we can actually pass NISH A, and we will see what is the output. So we'll say node, we'll say name GPT, and it just wouldn't us the end character. Oh, there's something. So it says NISH Nisha is the name, and definitely it also return N. So this is basically end character. So it said you don't need anything else. Nisha is a full name, but it can also return N, which say Nishan. N can be the next character. K could be a next character or N. So if you see, it's a receive N multiple times because it has a highest probability. But sometimes you do receive a different characters, which means Nisha could be followed by some other characters to generate some name. So yeah, let's write the function which can actually generate the name. And here also I'll assume that uh, I'll receive a start character from user and which will be this, by default this, and then let's print it. So the very first thing I'll do, I'll create a name variable which will hold this start string, and I'll run a loop where I'll ask it to generate the next random character. For that, you first get last n character of the string or the name you have. So your name could be 10 character long, but because n is only 5, so you want only the last 5 character. And then you ask your character generator to give me the next character. And if the next character is this, then you just break the loop. If it is not, then you just append the next character to the name, and then uh, yeah, it should work. And at last, you can just go ahead and return the name here. So let's see what it generates for us. Saida. So I think it's pretty better than the last time, the two bigram model which we have been using. And if I give NIS as a starting character, so Nishchay, Nishali, Nish, Nishk, Nisha, Nishu, Nisha. So you see, it is generating quite a few names based on the probability. So what I'll do now, I'll just run a loop. I'll generate a random 10 names. I'll say while I is less than 10. And 10 times I'll generate names. So let's see what does it generate. So you see, Sovar, Tapsyam, Sunita, Virpal, Arshala, Gaurav, Binu, Sobina, Shashi, Nashiba. So yeah, the names are pretty good, but there is one more thing we need to check. So Virpal, I would like to know if the Virpal is already there in my JSON. So let's search for it. You see, Virpal is already there. So basically, it uses the probability to generate the name which is already there in our final name.json. So what we can do now, instead of waiting for, instead of reusing the existing name, what I want to generate a random name which is not there in the final name. So let's first read on the final, on the Indian names, which I have already. And what I'll be doing, I'll be taking this name, and if the names includes, if already present in the Indian name, the training set which we have, then we'll not print that particular name. We'll just loop through and we'll wait for a different name. So let's see. So this time we should see all the names which are not there in our final name.json. So Satish. Let's see. So we copy this. There's one more thing which I need to fix. Satish is already there. What I need to fix is because see our names are starting with this, then Satish, but it didn't followed by the closing character. So I'll just append the closing character here so that it can match in our final names.json. Yeah. So now see Ruchita. So we'll take this name. Let's go to the Windows and we'll go here and we'll search for Ruchita. Now see Ruchita is not there. Let's take Ritika. So Ritika is not there. Dhanwaj. Okay. Dhanwaj is not there. So you can see the names which is getting generated now is totally new, which was not there in our database, and still the GPT model is able to generate this name. So this is pretty awesome. So yeah, with this, I will close today's lesson on how to build our own GPT. A few things before I close this, I want to add. This is a character-based GPT. The original chat GPT is much more complicated and much more powerful because it is word-based, basically token-based. Token is something similar to a word. So basically, it's a word-based GPT model. It have the ngram, which is basically the block size. So here I have five character block size. It have a way bigger number than this. It do understand sentiment of every word. So love is opposite to war. Your chat GPT do understand. Here, each character doesn't have a meaning. So the name GPT does not understand the sentiment out of that name or that character. After this, once we have our name GPT model ready, we should be able to figure out how strong our model is. So for that, we have to write our loss function. And using that loss function, we can tell if our model is good enough to generate names or not, or do we need to do some fine tuning on that. To do more fine tuning on this, we have to put this probability lookup table, which we created, through basically a neural network, and we can then modify, or basically we can tune our neural network so that the output is much better than what we are getting right now. And we will receive pretty meaningful name. So that is for the next chapter. We will come soon with that chapter. So if I receive 10,000 likes on this particular video, and if I know that people are really interested to learn how GPT works, then please give me a thumbs up. Once I receive 10,000 likes, I will make a video on how to basically put neural network on this so that we can fine tune our model, and as well as we'll come up with word-based GPT model. So basically, maybe Shakespeare GPT model. So we can give us entire Shakespeare novel to that particular GPT model, and then the GPT model can write a new novel for us just by using that existing novel which Shakespeare have, or could be a poem dictionary. So you put thousands of poems to this model, and then the model will be able to generate new poems for you. So yeah, uh, looking forward, 10,000 likes. This is what I'm targeting. Thank you, everyone. Thank you for joining.